In this section, we're going to be taking a look at the different types of compressor plugins that are available to us. Here we have our rock session again, and on the kick drum track, we'll go and open up our channel settings, and in our inserts, go to dynamics and see what we got available. So here we have the compressor plugin, which we used in our last example. We also have a tube compressor and a vintage compressor. We also have some frequency dependent compressors like the multiband compressor and the de-esser. So in order to understand which one we should pick, we should take a look inside of a compressor and see what makes each one of them unique. So inside of a compressor, our audio comes in and is sent to an amplifier. That same signal is split and sent to our gain reduction circuit, which detects the level of incoming audio. The gain reduction circuit controls the volume of the amplifier, and the resulting audio is then sent to our audio output. The biggest difference between compressors are the components that are used for the gain reduction circuit. The first type is controlled by a transistor, also known as a FET. These are typically very fast to respond and give us a faster and more accurate gain reduction. The second type is an optical or opto circuit. This uses a light and a light sensor. The incoming volume controls the brightness of a light source. The light is then received by the sensor, which then controls the volume of the amp. These are typically slower to respond, but have a smoother sound. The third type is a tube compressor. Most tube compressors are optical compressors that have extra tubes in the circuitry. And like optical compressors, they'll usually have slower response times. However, because of the tubes, we'll get some extra harmonics in our sound, which can really make dull tracks come alive. So FET compressors, because of their fast response times, are often a popular choice to use on drums, acoustic guitar, and bass guitar. So let's go ahead and check out our vintage compressor and see how we can use it on this kick drum track. So for some of you, the layout of controls may look familiar. It resembles a popular FET compressor known as the 1176. And for those of you who aren't familiar with it, you'll notice immediately that we don't have a threshold control. The only thing that we have to control the amount of gain reduction is our ratio controls here and our input knob. The farther we turn up the input knob, the more gain reduction we get. Our output knob we can think of as our makeup gain. We also see a few familiar controls for attack and release. Our ratios are fixed values at 2:1, 4:1, 8:1, and 20:1. This meter in the middle represents our gain reduction meter, and off to the right we have our input and our output meters. So let's go ahead and play our kick drum track, and we'll take a look at how the input knob affects the amount of gain reduction. So you saw that by increasing our input, we were able to get more gain reduction, which resulted in decreased dynamic range, but also increased volume. Now with this particular plugin, we have to take special consideration to our input and output meters. Once we've increased our input, we have to make sure that we decrease our output so that we're not clipping. Another unique setting in this plugin is that we have a punch button. The punch button gives this compressor more attack, and it gives some characteristics that are typical to opto compressors. One thing I've noticed when using this punch button is that when it's engaged, the attack setting has very little effect on our transient. So let's see what the punch button does for our kick track. I'm sure you could notice when we engaged the punch button, we heard a lot more of the attack of the kick drum. And these slower response times are something that are great for vocal tracks. So let's move on to our next plugin, which is the tube compressor. So on the tube compressor, we'll notice some similarities with our vintage compressor. We have an input knob, which drives the gain reduction. We have our output knob, which controls our output volume. We have attack and release settings. We have our gain reduction meter, and we have our input and output meters. One thing you'll notice that we're missing is our ratio control. The ratio is actually set internally and there's no way to adjust for that. We do, however, have a limit button, which activates higher ratio values for limiting. On this plugin, we actually have a drive knob, which increases the amount of tube saturation, and we have a mix knob, which gives us something called parallel compression. Parallel compression, also referred to as New York style compression, is an effect that's used to get a solid compressed sound while retaining our original transients. And we do this by blending the uncompressed signal with the compressed signal. So with our mix knob set to 100, we're listening to 100% of the compressed signal. As we start to move this mix knob down, it starts blending in the uncompressed signal with our compressed signal. We also have a section for the internal sidechain on the unit, which we'll be discussing in the next section. And this gives a way for the gain reduction circuit to only respond to certain frequency bands. We have a low pass, band pass, and high pass, and we can also adjust those frequencies by using the center knob and the Q factor. So go ahead and reset our settings here and listen to our kick drum track to see what the tube compressor sounds like. So you can hear by increasing our drive knob, we start to get more harmonics from the kick drum. This can be really useful to liven up tracks that might sound dull or might lack harmonic content. So now we'll start by taking a look at our frequency dependent plugins. For this, we're going to go ahead and pull up our bass track. And we'll go and insert the first plugin, which is going to be the multi-band compressor. We'll go and reset our settings here. So automatically we'll notice some familiar controls. We have a threshold, we have a ratio, we have an attack, and a release with an auto button. Now you'll see the one thing that's different is that we have 4 different compressors. Each one of these compressors correspond to a specific frequency band which is set above. The frequency bands are adjustable by moving the center slider right and left. The makeup gain can be changed by moving each specific frequency band up and down. We can listen to each specific frequency band by pressing the solo button, and we can bypass compression on those specific bands by clicking on the bypass button. Let's go ahead and listen to our bass track and see what we can do with the multiband. So you can hear in this last section, we have a couple of low frequency notes that are really coming out at us. And this is where the multiband compressor comes in handy. It lets us compress only specific frequency bands. So if we have low frequencies that seem to be uneven, we can compress those specific bands. Let's go ahead and listen to this section again and narrow in on those notes. It's right in those accented notes. So the first thing we'll do is go ahead and solo our low frequency band. We'll adjust our frequencies that correspond to that, and then we can start playing with the compression settings. So you can see on those accented notes where the compressor is applying more gain reduction just for those lower frequencies. Go ahead and solo our mid band and see if we can get that under control. And then we'll go ahead and solo band 3 and see if we can get some of the pick sound under control. Now the other nice thing about the multiband compressor is we can kind of use it as an EQ by using the makeup gains to adjust the volume of each specific frequency band. Let's go ahead and try to bring down the volume of some of the pick sound. So you can hear how we've gained control of some of the low frequencies and we've been able to use the makeup gain to balance out some of the high frequencies. Let's go ahead and bypass our plugin, and then we'll enable the plugin and see what kind of difference it's made. You can hear how we've really been able to even out some of the inconsistencies across the whole frequency spectrum. Next, we'll take a look at the de-esser on our overhead cymbal track. On this plugin, we have a few controls, one called reduction, one called threshold, and one called release. The reduction we can think of as our ratio setting. By default, the threshold is set to auto, so we'll just go ahead and uncheck that and move each control back to 0. Go ahead and play our cymbal track and see what we got. And similar to the multiband compressor, the de-esser only compresses a specific frequency band, usually in the 5 kHz to 8 kHz range. And it's useful for vocal tracks where there's a lot of S sound coming from the vocals, but it's also useful on overhead cymbal tracks where some of the high end might sound harsh. Let's go ahead and check it out and see what it does. So you can really hear when it's enabled how it cuts some of those harsh high-end sounds out. The auto threshold setting makes it really easy to set up. It'll automatically detect the threshold of the incoming audio at that specific frequency band, and all we have to do is change our reduction setting. So that's it for this section. Stay with us in the next section where we start talking about sidechaining.